In this lesson, we will quickly learn how to plot hyperbolic functions, what are their domain and range. See, this lesson is very important since for any function y equals to f of x, we must know what set of values we can put in place of x so that we will find a real value at y. And those values or that set is domain. The set of values we can put in the function f. And what is range? The set of output values, the set of results that we will get after putting all the domain, that is range. And what is graph? The structure of the function on Cartesian plane, how they look like in Cartesian plane. So before going into the graphs of hyperbolic functions, first we must know how to plot exponential functions, because hyperbolic functions are built from exponential functions. Say we have this is our y-axis, this is our x-axis. So first we should know how to plot exponential e to the power x. E to the power x, that function looks like this one. At 0, when x is 0, this is x, this is y. When x is 0, we have e to the power 0 1, so this height is 1. And when x gets bigger and bigger, e to the power x gets bigger and bigger. So the heights at x for large value of x, they will grow exponentially. And in negative side, when x is large negative, e to the power x is very small and they will go towards 0. So when x gets large negative, this height, the height is going very close to 0, but they will never meet the x-axis. So this is our e to the power x. What is half e to the power x? Half e to the power x means if y equals to half e to the power x, that means if you know y equals to e to the power x, then you also know y equals to half e to the power x, because at any small x, this height, this is the graph of y equals to e to the power x, so this height is e to the power x. So what is half e to the power x? Y is half e to the power x means this height will be half. So at any point, your height reduced to half. So what is half e to the power x? That will look like this one. This is our half e to the power x. Let us make that a significant graph. This is our half e to the power x. So this is ex, this is half e to the power x. What is e to the power minus x? E to the power minus x. If we know y equals to f of x, we also know the graph of y equals to f of minus x. And this graph is just reflection of y equals to fx graph and treating y as a mirror. So if this is e to the power x, and we will treat this one as a mirror and we will reflect the graph. So the graph of e to the power minus x looks like this one. Let me so this is e to the power minus x. E to the power x reflected, treating y as mirror. Next, we should also know what is half e to the power minus x. By the same logic, we have half e to the power minus x. This height, all this height will be get reduced to half. This is half e to the power minus x. So if we know y equals to f of x, y equals to f of minus x is the reflection of that graph, the graph of y equals to f of x, treating y as a mirror. The graph of y equals to f of x minus y equals to minus f of x, the graph of this function is the reflection of this graph, treating x as a mirror. So the graph of, what is the graph of, suppose we want to know the graph of minus half e to the power minus x. So this graph will be reflected, treating x as a mirror. The graph of minus half e to the power minus x looks like this one. This is minus half e to the power minus x. So we know if y equals to f of x, we know the graph of y equals to f of x. So this graph is the the collection of all heights gets reduced to half. Graph of f of minus x, reflection about y axis, y equals to minus fx, reflection about x axis. With this much preliminary, we are ready to plot hyperbolic functions. First, we will plot hyperbolic cosine x. This is by definition e to the power x plus e to the power minus x by 2. We can write this one as e to the power x by 2 plus e to the power minus x by 2. We already know how to plot half e to the power x, also half e to the power minus x. We are only left to add them. So this is our Cartesian plane. We have y-axis, x-axis, x-axis, y-axis. Please refer to previous. We have e to the power x by 2, looks like this one. And let me plot that. This is e to the power x by 2. And what is e to the power minus x by 2? That will look like this one. This side is half. At 0, e to the power x or e to the power 0 by 2 is half. So this is e to the power x by 2, and that will go through y axis at half. So does for e to the power minus x by 2. At 0, we have e to the power minus 0 by 2 is a half. This is e to the power minus x by 2. So this, now let us add them. At origin, when x is 0, both are half. So half plus half is 1. So hyperbolic cosine will take the value of 1 at origin. And when x gets bigger, the e to the power minus x by 2 comes closer to 0. See, both heights are positive. This side at any x, we have this side above x-axis, this side also above x-axis. This is by e to the power minus x by 2, and this is this side for e to the power x by 2. And all these heights are value of y. Y equals to e to the power x by 2 means this height is the value of y. This side is the value of y for e to the power minus x by 2. And when they will get added, the graph will be above these two graphs. And when you add for large x, you are adding small heights. So the graph of hyperbolic cosine will look like this one. When you are going for x large, the height above e to the power x by 2 is this side. So these are small heights and they are going to 0. So this will tend to approach this curve, but they will never intersect. And so for negative x values, the hyperbolic cosine will look like this one. This is a rough sketch, and this curve has a name. This name we say catenary. This is not hyperbola. This may look like hyperbola. This is but this is not hyperbola. This is catenary. Like parabola, circle, line, this curve has the name catenary. And catenary comes from the word when you hang a freely hanging chain. Let's say this is our chain. When it is hanged at its ends, the structure it gets, we say that catenary. This structure is catenary. This is not parabola, this is catenary. The hyperbolic cosine takes the shape of this catenary. From the graph, we can see the domain and range. What is domain of hyperbolic cosine? Domain means the set of x values it can take. For any x, you have a height. For any real x, so domain is the set of all real numbers. For any real number, you have a height, so you have a y value. So domain is the set of all real numbers. What is range of this hyperbolic cosine? Range of a function means the set of y values, and the y value starts at 1. This is goes up to infinity. So range is 1 to infinity, 1 is closed. Also note that this function is an even function. The graph at positive x and negative x, they are just reflections of each other. So this is an even function. The value of hyperbolic cosine at x is same as at minus x. If you put 1 at the place of x and put minus 1 in the place of x, they will be same. After plotting hyperbolic cosine, it will be easy to plot hyperbolic secant because it is just the reciprocal of hyperbolic cosine. See, hyperbolic cosine takes the value between 1 to infinity. The heights are bigger than 1 and it goes up to infinity. When you take reciprocal of those values, they will lie between 0 to, if this is our suppose say z, then z will lie between 0 to 1, because 1 over any positive value which is bigger than 1, that is less than 1, and it can't be negative, also it can't be 0. So hyperbolic secant takes the form this one. When you go for large x, the heights gets larger and the reciprocal of those heights, 1 over large values, will get closer to x. 1 over, suppose large value, we have 1 lakh. This is just 0.00001, which is closer to 0. So if you increase the value of denominator, it will get closer and closer to 0. And so for negative x, because this is even function, they are reflection of each other. So for secant hyperbolic, they will be also even and reflection of each other. So what is domain here? Domain of hyperbolic secant is the set of all real numbers. You can put any real number, you will get a real value of y. What is range? Range is 0 up to 1. 0 is open, 1 is included. This is also an even function. Next, we will proceed to hyperbolic sine. We have hyperbolic sine by definition e to the power x minus e to the power minus x by 2, which can be written as e to the power x by 2 minus e to the power minus x by 2, and this is our Cartesian plane. We already know e to the power x by 2, and this is e to the power minus x by 2 minus e to the power minus x by 2. Now we want to add these two graphs. This is half at 0, this is 1 over 2. At 0, this will be e to the power minus 0, 1 by 2 minus half, so this is minus half. And when you add them, half minus half, this will be 0. So sine hyperbolic will go through origin. And when you go for large x, this value gets bigger and bigger, and e to the power minus x by this graph gets closer to 0, but in negative side. So you are adding small negative to this graph. Small negative to this graph means this graph will go closer and closer to this one, but will be at lower height because you are adding negative values. And when you go for, this is not straight line, this is a curve. When you go for large negative, these value are very large negative, y value is very large negative for this graph, and here you have small positive y values. So when you add them, they will get also large negative, but they will be up above this one. So this will look like this. This is a rough graph, this is not straight line. This is hyperbolic sine. Its domain, all real numbers. You can put any x and you will get one y value. And what is its range? Range is also all real number, because all heights, the graph takes all heights. Here domain is set of all real numbers and range is also set of all real numbers. If you can put any x, you will get a y value, and you have all y values starting from minus infinity up to plus infinity. So range is whole real numbers, domain is all real numbers, and this is an odd function. This is an odd function. From graph we can know odd function by the following logic. Look at the positive x-axis. The graph looks like this one. and if you reflect by y-axis, the graph will look somewhat this one, and when you again reflect by x-axis, the graph will be this one. So if the graph in negative part of x is two reflections by y-axis and by x-axis, then that is an odd function. Also you can verify that hyperbolic sine of minus x is minus hyperbolic sine x. That means sine hyperbolic minus x is minus sine hyperbolic x. You can put minus x in place of x and check that is minus hyperbolic sine x. Next we have the reciprocal of hyperbolic sine, which is hyperbolic cosecant. Here we have hyperbolic sine, and note this thing, 1 over small is large, that and 1 over large is small. When you have large quantity, its reciprocal gets smaller and smaller. When you have smaller, then that reciprocal becomes large. So when you go closer to x-axis, the heights gets closer and closer to 0. So its reciprocal will gets bigger and bigger positive, because heights are all positive in positive x-axis. So cosecant hyperbolic will go towards infinity when you approach towards 0 in x-axis, and when you go to larger x value, the heights are very large, so its reciprocal will go closer to 0. So in first quadrant in positive x-axis, the graph of hyperbolic cosecant looks like this one. Also for negative x, for minus x, what we have, when x gets larger negative, the heights are very large but in negative, so its reciprocal will go towards 0 but in negative side, and when you go closer to origin, the heights are smaller negative values, they go to 0, so it will be large when you take reciprocal. So this is our hyperbolic cosecant in negative x-axis direction. This is cosecant hyperbolic. At 0, cosecant hyperbolic has no value, because sine hyperbolic is 0 and 1 over 0 is not defined. So its domain is set of all real numbers taken out 0. Remove 0 from all real numbers, so you have all non-zero values as domain. And what is its range? Range is also all real numbers, 0 removed. So range is all non-zero values. Also type of this function is odd. If a function is odd, its reciprocal is also odd. So this is odd function because sine hyperbolic is odd. We are left with last two hyperbolic functions, hyperbolic tan and its reciprocal hyperbolic cotangent. So hyperbolic tangent, this is hyperbolic sine by hyperbolic cosine, or we have e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. See, the denominator is larger than numerator because e to the power x, e to the power x are same. You are taking out small, this is also positive, e to the power minus x positive, e to the power minus x positive, and you are taking out some positive value from e to the power x, but in denominator you are adding that value, so this is bigger than this one. So when denominator is larger, we have the value of reciprocal less than 1. So value of hyperbolic tan can never be bigger than 1, and same for negative side, it can't never be bigger, lesser than minus 1. So this is our y-axis, this is our x-axis. So the hyperbolic tangent, this is our y equals to 1, this is our y equals to, let's say, minus 1. Hyperbolic tangent lies between these two curves, and when you go towards large value of x, for large positive value, e to the power minus x goes to 0. So this quantity is very small, this quantity is very small, and these are very large quantity. So for large x value, this quantity will dominate. and since they are same, their ratio will go to 1. So at large x, this value will approach this y equals to 1. At 0, hyperbolic sign is 0 and this is 1. So at 0, the y value of hyperbolic tangent is 0. So this graph will go through origin. And for large negative, e to the power x goes to 0. When x is large negative, this goes to 0, this goes to 0. They will decide where hyperbolic tangent will go. So this is 0, 0. And what you are left with? Minus e to the power minus x plus e to the power minus x. They are same. Their ratio will go towards minus 1. So for large negative, you have hyperbolic tangent look like this one, and they will go through origin, and the graph of hyperbolic tangent will look like this one. It will never touch this one. Also y equals to minus 1 line. So this is hyperbolic tangent. What is its domain and what is its range? Domain means set of all x values you can put. You can put any x, you have one height. So domain is set of all real numbers. What is its range? Range lies between the set of all y values. Y values lies between 1 and minus 1. 1 and minus 1. It never touches 1. So 1 open. Sorry, this is minus 1 to 1. Minus 1 open. Also 1 open. This is range. This is domain. This is also an odd function. This part reflect this one by y-axis and again by x-axis, you will get this curve. So this is an odd function. Next we have hyperbolic cotangent, which is reciprocal of hyperbolic tangent. We have already seen hyperbolic tangent. This looks like this one. At origin, the y value of hyperbolic tangent is 0. So at x equals to 0, the reciprocal 1 over 0 does not exist. So 0 does not comes in the domain. When you go towards 0, the heights get smaller, 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 goes to 0. So its reciprocal will go towards infinity. And when you go towards large x, the heights approaches the line y equals to 1. The values of hyperbolic tangent go towards 1. So its reciprocal will also go towards 1, but bigger than 1, since this is smaller than 1. So in positive x, we have hyperbolic cotangent looks like this one. And by the same logic, since this all are negative, the hyperbolic cotangent looks like this one in negative x part. What is our domain? Domain is set of all real numbers excluding origin, excluding 0. What is range? For range, we have minus infinity to minus 1, union 1 to infinity. Since these values from minus 1 to 1 including is not included, because no, for the curve of hyperbolic cotangent, there is no height which lies between minus 1 to 1. So we have excluded those from the range. So range is real numbers minus 1 up to 1, which is minus infinity to minus 1, union 1 to infinity. This is our range. And what is its type? Type is odd function, because hyperbolic tangent is odd. Its reciprocal is also odd. When we learn any new function, it is crucial to know what set of x values we can put in the function, and what are the set of outputs, what y values we can get, and how they look on Cartesian plane, and is there any symmetry, it is odd, it is even. And if you have any doubt, please comment and I will try to answer them. Thank you.